Bienvenidos, Ushamadid, and welcome UMGC learners from the CMIT-455 Section 6380 course for the spring 2021 semester. This is the CCNP ENCOR version 8 curriculum from the Cisco Networking Academy, and in this supplemental video tutorial for Chapter 15, we're going to be taking a second look at Multigroup HSRP. But this time, we're going to be looking at using different VLANs. And so again, Multigroup HSRP is all about the ability to load balance the traffic from the nodes that are using the routers as their first hop. So how can we spread that traffic out to balance things? In the previous video, we looked at doing this for nodes, PCs, laptops, printers, whatever the case may be, that are all in the same VLAN. Now, in this video, we're going to take a look at how we would do that using different VLANs. So let's come back to Cisco Modeling Labs and let's take a look at that. And here's our configuration. It has not changed. What has changed is that PCB is now VLAN 20 and PCA is now VLAN 10 as it was before actually. And so what we want to do is we want all traffic for VLAN 20 to flow this direction, and we want all traffic for VLAN 10 to flow this direction. Now, if for whatever reason there was an issue with the interfaces that are the LAN-facing interfaces on router 1 and 3 respectively, in this diagram, gig 03, we want that traffic to then go ahead and cross our Ether channel link here. This is an LACP port channel that is configured. And so we would have a backup. Again, if you look at this and you say, well, why don't you just set it up so that the default gateway is the interface on router 3? Well, we could certainly do that. The problem is that what happens when that interface goes down? If we're not running HSRP, that means that PCB is done. Game over. Not going to be able to get out to the internet. And again, we're simulating the internet with a loopback address out here. And the same is true of PCA. If we hard code the default gateway address on PCA to be the physical interface IP of router 1, and this link goes down for whatever reason, it's game over right there for PCA if we're not running HSRP. So, how do we do multi-group HSRP now that we have two VLANs? So you might be looking at these links right here and saying, well, wait a second. These were access ports on the switch. How is that going to work now? That you want it to fail over and come over here for VLAN 20, and then you wanted it to fail over and come over here for VLAN 10. Well, we've got two choices that we can make here with routers as our layer 3 boundary. And again, if I was to draw like a little line through here, right, here is our layer 3 and here is our layer 2 boundary. We've got our layer 2 switches down here and our layer 3 routers up here. So what I could do is I could take another interface on router 1 and then drag a connection down here to switch 1 and make that VLAN 20 while this one remains VLAN 10. And I could do the same thing over here on router 3. Take another physical interface on router 3 and drag it down to switch 2 and make that VLAN 20. And then we would have physical dedicated interfaces servicing each of the individual VLANs. Sure, you could do that. But again, let's talk use case. If I've got 20 or 30 PCs over here that are in VLAN 10 and 20 or 30 PCs over here in VLAN 20, do I need to dedicate another gigabit Ethernet interface here? Or could I get away with doing sub-interfaces and just make this a trunk link and we do router on a stick? Because there's nothing that says we can't do router on a stick in multi-group HSRP. Just nothing says we can't do that. So it's going to come down to use case. Is it just web traffic? Is it no big deal? Hey, if they're heavy hitters, maybe we do dedicate a physical interface between the switch and the router for each of the VLANs, but then we start to chew up a lot of interfaces. So things to think about. But again, we're going to do sub interfaces, router on a stick configuration, And the first thing that I had to do, and again, to kind of shorten this up so that you don't have to see all the behind the scenes work, is I had to create VLAN 20 on switch 1. And again, I had to create VLAN 20 on switch 2 because it did not exist previously. So these are both in server mode. I could easily make them transparent mode, no need to, but VLAN 10 and 20 exist on both switches. That way VLAN 10 and 20 are both being forwarded across the LACP port channel, and they can make it up to their sub interface. And the sub interfaces have actually already been configured as well. So I'm going to save that writing right there, and let's go ahead and dive in to the HSRP, the multi-group HSRP configuration that we're going to be using here. So let's go from user exec to privilege exec into global config. If I say do show IP interface brief, you'll be able to see that we have two sub interfaces, gig 03.10, gig 03.20. Again, 3.10 for VLAN 10, 3.20 for VLAN 20. So let's jump into interface gigabit 03.10, remembering that this is the primary, the active HSRP router because it's closest to PCA and all of the other PCs that would be in VLAN 10. So I'm going to say standby version 2. We're going to say standby. Now, what are we going to use here? Well, I'm going to use standby 10 because we're not dealing with the same VLAN here. We're dealing with different VLANs. So why not match the standby number to the VLANs? So I'll say IP is going to be 192.168.10.254. We're going to say standby 10 priority 200. We're going to make sure that this is going to be the active HSRP speaker. And then I'm going to say standby 10 preempt. Because if that interface were to go down for some reason and come up later, or it could even be the interface on the switch that goes down and comes back later, we want router 1 to take over the responsibility and the role as the primary when it comes back up. That way we don't have VLAN 10 traffic spanning our LACP port channel over here to switch 2 and then up to router 3. Again, defeats the purpose of the load balancing that we are going to be configuring. So now let's come over here to switch 1, and ever so briefly, let's just take a quick look here, and we'll get into privilege exec, and we'll say show MAC address table. Because what am I looking for? I'm looking for my VLAN 10, and there it is, an A in hex has a decimal value of 10. So easy to spot, right? And it's easy to spot based off that Charlie 9 Fox in the center there, right? Or sometimes you'll just look for fox.fox. But this is the virtual MAC address that corresponds to the virtual IP address 192.168.10.254 that we just configured. And take a look. What does switch 1 say is the quickest way to get there? Yeah, right up gigabit 03 to router 1. Let's take a look at switch number 2, and let's see if that information's made it over here to switch number 2. We'll jump into privilege exec, show MAC address table. And we see that very familiar Charlie 9 Fox, or the fox.fox, and it says exactly what we would expect. Because again, it's being advertised. The virtual IP and MAC are being advertised to switch 1. Because router 1 is the active for that HSRP group. So switch 2 says go across the LACP ether channel, or the LACP port channel. All right, so that takes care of that. So let's come over here and let's go ahead. Let's say do show run int gig 03.10 for VLAN 10. And we take a look at that. We're pretty happy with that, right? Great configuration. Let's get into interface gigabit Ethernet 03.20. Now, remember, this interface, sub-interface, I should say, this sub-interface, router 1 is the standby over here. So let's say standby version 2, because we still want to run version 2. Maybe there's some timer work we're going to be doing later. And let's go ahead and say standby 20. And the IP address here is going to be 192.168.20.254. And again, I like 254 as my default gateway address. So we've got two different VLANs here. Why not use 254 for both? And then we're going to say standby 20, remembering that HSRP group number. Oops, sorry. And do we need anything else? That's my question to you. Do I need to set the priority? Could I set it to something below 200? Sure. But 100 is already below 200. Why not just leave it? Do I need to preempt? No, because it's going to know that it's going to take over the role. And you can see here, it thinks it's active right now, but wait until we get over to the other side, to router 3 side, where we configure the preempt command. We don't need the preempt command here because it's going to fail over auto-magically anyway. The preempt is on the node that is the active node that we want to be the active node, that when that node comes back up online, if it had gone offline, that it takes back over the primary responsibilities. It is the active HSRP speaker. So I think we're good here. So let's go ahead and say write mem. All right, well, let's do a quick test on PCA. And let me ping 209.165.200.201. Can I ping the internet IP? Excuse me. All right, well, let's check a few things. Now, we may have to take a look at these PCs. Let's cd into Etsy network, and let's go ahead and say cat interfaces. And what am I using as my default gateway? Well, there we go. Remember, this is left over, so let's say sudo vi interfaces. And again, I enter my password for Cisco, which is Cisco. We'll come down here to the gateway statement. We'll do an R and then hit the number 4. R meaning replace, and we're replacing the 0 with the 4. Hit the escape key, Shift ZZ, and let's CD back here. And so here's what I'm going to do. I probably should have done this last time at the very beginning, but let's say sudo service and not restart, networking and restart. So let's restart the networking services here on this host. Again, changing the default gateway. We want to make sure that that gets done. Let's clear our screen and let's ping 209.165.200.201 and let's see if we've got reachability. All right, not pinging even with the default gateway properly set here. Let's see. Can I ping the physical default gateway? 192.168.10.1. All right, so I can reach that, but I can't reach 10.250. I'm sorry, 10.254 I can reach, and the question is, can I reach all the way out to the 209.165.200 dot? Oh, and you want to know what I think it is? I know exactly what it is. So I am not advertising my OSPF information. So let's get into Gigabit Ethernet 03.10, IP OSPF1 area 0, int gig 03.20, IP OSPF1 area 0. And you might be wondering, well, how did you think of that? What popped into your head? Well, it was because I was able to ping the physical interface. I'm able to ping the virtual IP. And so everything was working before, and I know the 209 address is out there. So it had to be reachability possibly on the way back to me. And let's come back over here and let's see if I now, and we're going to probably have to ping a real IPv4 address. And there we go. Because the 209.165.200.201 router 2 now knows how to get back to that 192.168.10. And again, we're going to do the same thing over here on router 3. So let's jump onto router 3 and let's go from user exec into privilege exec into global config. Let's say do show IP interface brief. And you can see here, I've got my physical, or I should say, the physical interface gig 03 carved up into 2 sub-interfaces. And now let's do our HSRP and our OSPF configuration on these sub-interfaces, int gig 03. And so let's go ahead and start with IP OSPF1 area, area 0. And then let's get the, oh, I'm sorry, I did not want that on the main interface. I just saw that. Let's say Control A, we'll say no. Int Gigabit Ethernet 03.10. There we go. Excuse me. And we'll pull that command back up. All right, so now here we're going to say standby, and we'll do the primary side. We'll do the primary VLAN that router 3 will be servicing first. So actually first, let's say standby version 2. And then we'll say standby 20. IP is going to be 192.168.10. 20.254. And overlaps. Did I already have this do show IP? Hold on one second. IP interface brief. 0320, and let me make sure I've got that do show run int GI 03.20. Let's make sure I don't have a typo going on here. I got my, oh, you know what I did? Do show run int GI 03.10. Did I go into the wrong sub? And I did go into the wrong sub interface. So yeah, let's get into interface gigabit Ethernet 03.20. Let's say standby version 2. IP address is going to be, oops, sorry, not IP. Standby 20 IP is 192.168.20.254. And I apologize. What was going on there was I was under the gig 03.10 interface, not thinking to get under the 20 interface, which is where we're going to be doing the configuration for the primary setup. So let's finish this out. Standby standby 20, and we'll set the priority to 200, and we'll say standby 20 preempt. And you can see right there that it went from speak to standby. I dropped the preempt in, and now router 3 is advertising HSRP hellos that router 1 is seeing. And it says, hey, my priority is 200, and I'm set to preempt you if you think you're the active and your priority is lower than mine. Or if your priority is the same as mine, and I have a higher IP address on my interface, which in this case, we do because it's router 3. All right, so let's say do show run int GI03.20, and let's get the right subinterface here. So I've got my NCAP.1Q router on a stick ready to go, the physical IP version 2, the virtual IP, my priority, my preempt, everything looks good. So now let's go to gigabit Ethernet 03.10, and let's do the standby configuration for VLAN 10 on router 3. I believe I've got the standby version 2 on here, but we'll run it again just to be sure. And then I'm simply going to say, and you know what? I need the IPOSPF1 area 0 on the other side. So we'll say standby 10 IP 192.168.10.254. So I think I've got the IP. Let's just run it again to be sure. IPOSPF1 area 0 int gigabit Ethernet 03.20, and then let's go up arrow twice. And now we've got that configuration command in there, and we should be good. Let's say do show run interface gigabit Ethernet 03.10, and that's the only config. And you can see right there, group 10, I am the standby. And let's go ahead and put in group 20. And again, we've got a little more configuration, but that's okay. So let's say in, let's write mem just to be sure. And now let's come to PCB. It's PCB's time to shine here. So first of all, let me go ahead and say cat etc network interfaces, and let's see if we are set up here. So we are on this side. So this PC is all set up, ready to go. Can it ping the physical IP, 192.168.20.3 of router 3? It can. How about router 1? Absolutely. I'm just going across that LACP port channel. I can get to router 1. How about the virtual IP, 254, my default gateway that I'm depending on in case the physical interface on either the switch or the router 3, in this case right here, if either of those interfaces fail, I need to make sure that I can still come over to router 1. And so now let's test out, can I ping the 209.165.200.201? And I can get to the internet. But now is when the rubber meets the road. Now is when we're going to test our multi-group HSRP configuration to see, am I able to fail one of these interfaces? And does traffic auto-magically reroute for me with HSRP? And again, I could come to switch 2 here, and we jump into privilege exec real quick and say show MAC address table. We've seen this, right? And so what are we looking at here? That is my native VLAN. Not interested in that. I'm looking for, there's VLAN 10. And you can see it says right now, because again, for VLAN 10, we want traffic coming over here. as the primary. And then for VLAN 20, there's my 0 Charlie 9 Fox. And what does it say? Yeah, it says, hey, shoot right up to router 3. That's where we want to go, because here's where we can come back and validate after we fail. And let's fail on router 3 side. So is my ping going over here? Let's kick off the ping. We're going to let the ping go. I'm going to come to, and I did not want to do that. Hold on one second here. Let's see if I can shrink that down a bit. There we go. We'll leave it right there. All right. So I'm going to come over here to router 3, and let's go ahead and get into global config interface gigabit Ethernet 03. Let's shut. And actually, let's just shut the sub interface down. 03 to show you that you can do the parent interface, but then that would kill the VLAN 10 standby. So let's go ahead and just jump into 3.20 and shut down that sub interface. Let's quickly move back to the PC and take a look at that. Seamless. Traffic still going out to the internet, but now if we get onto switch number 2, and I'm going to try to shrink that down a little bit if I can here. It's not cooperating. Sometimes the mouse will move around and not cooperate very nicely. I got to try to line up the, maybe that's where, oops, sorry, maybe that's where we wanted to be. Sorry, just trying to line this back up. There we go. All right, so let's come to switch number 2. And let's go ahead and now say show MAC address table. And again, we could trim this down. I could say VLAN 20, and it would only show me the interest for VLAN 20. And so that's what we're interested in. So now, where at layer 2 does switch 2 say that traffic looking for that MAC address 0 Charlie 9 Fox, which is the virtual, which is now over here on router 1. It says to go across the LACP ether channel. And you can see for group 20, my state is now active. Show standby, show standby brief. And here you go. My 3.20 sub interface for VLAN 20, the priority is 100, the default. I don't need a preempt because again, I'm the standby. And when the active primary comes back up, router 3, we want the control to be handed back over. There's a preempt statement over there. You can see here my state is active. There's the virtual IP being used. The standby, I don't know because I can't communicate with him right now. He's down. All right, well, let's go ahead and bring it back up and let's see. Say in, throw right mem in here, and let's jump back on PCB. How does it handle it? Seamlessly. And there you go. Let's take a look here at switch 2. Let's do a show MAC address table VLAN 20. Now where does it say? Yeah, gigabit Ethernet 03 goes straight up to router 3 because it's active, it's back up. And now it is advertising the virtual IP and the virtual MAC address, and the MAC address you see right here. So the only thing we need to test now is the same thing that we just tested for PCB. Let's get into global config, and before we do that, let's kick a ping off here on PCA, and let's say ping 209.165.200.201. And it's working great, but let's see what happens. Junior engineer comes in here, unplugs the wrong cable, 03.10, and or shuts the wrong interface down, maybe in a change window, who knows? Doesn't skip a beat. Now, we've got a little latency that's been added on here, no doubt, a couple milliseconds, but traffic continues to flow, right? Let's look at switch 1, and let's say, in privilege exec here, let's say show MAC address table VLAN 10. And where are we going now to get to the virtual MAC that's tied and associated with that virtual IP default gateway of 192.168.10.254? We're going across the LACP ether channel, port channel 1, over to switch 2, because now router 3 is the primary. Show standby brief. Router 3 is the active HSRP speaker, and you can see it right there. I don't have the preempt flag here. We didn't configure the preempt because it's supposed to be the standby. Now, if I had multiple other routers, that's a different conversation. But with these two routers here, we're good to go. So let's see what happens. We're still pinging. We're still pinging. Things look great. We'll jump on to router 1, and I'm simply going to say no shut end and then right mem. Let's come back to PCA, and it's working like a champ. We did not skip a beat. All right, well, that is going to do it for this supplemental video tutorial for Chapter 15, where we took a look at HSRP, and what we're looking at in these supplemental tutorial videos on HSRP is multi-group, or MHSRP, and we looked at it in two different use cases. We looked at a use case where you've got a single VLAN and we want to do load balancing with HSRP groups and split the VLAN up. And we looked at multi-group HSRP using different VLANs. And in this use case, we did router on a stick with sub-interfaces, and we showed that it worked beautifully. Could we have used dedicated interfaces? We absolutely could have. And then on the switch side, we would have made them access ports in the respective VLANs. But with the sub-interfaces, we saved a router interface. And again, our use case, maybe we don't need that much throughput and we're not going to be oversubscribed in a terrible fashion. All right. Thank you guys so much for watching. Hopefully this explains load balancing with multi-group HSRP. Thanks so much for watching, and I hope to see you in the next video.